A very good morning to one and all. Today we'll be demonstrating the experiment total acidity. We are going to determine the total acidity of any given water sample or wastewater sample in the laboratory. So what are the various reagents required? It is sodium hydroxide of 0.02 normality, phenolphthalein indicator, methyl orange indicator. These two are the indicators, and the titrant used is 0.02 normality sodium hydroxide. So we have the samples which will be taken for carbon dioxide acidity sample and mineral acidity sample. We are going to determine where the total acidity is the sum of carbon dioxide acidity and mineral acidity. So the principle, theory, everything was explained. You will be observing how the titration is going to be carried out. So it is in two parts, where in the first part we will be determining the carbon dioxide acidity, and in the second part we will be determining the mineral acidity of the given water sample. So you know the apparatus, it is the burette. Okay, then we have measuring jars, beakers, conical flask. We will be taking the sample, measuring the sample 50 ml and placing it in a clean conical flask. You all can just observe the titration. So 50 ml of the given water sample whose total acidity is going to be determined is measured. 50 ml is being measured. It is going to be placed in a clean conical flask. The burette is already filled with the titrant sodium hydroxide of 0.02 normality. Now the indicator used is phenolphthalein indicator. You are going to add 3 to 4 drops of phenolphthalein indicator. It remains colorless. You have to titrate against sodium hydroxide of 0.02 normality till the color changes from colorless to pink. So initial burette reading you will be noting down, final burette reading you will be noting down, and volume of titrant used, V, you will be noting down. So the end point is colorless to pink. So this gives you all carbon dioxide acidity is equal to V into 1000 divided by volume of sample taken in mg per liter. You will be getting carbon dioxide acidity. The second part, you will be determining the mineral acidity for the same sample. So you will discard the sample, clean the conical flask with distilled water. Then again measure 50 ml of the sample. Okay, you will place it in a conical flask. So we have already determined carbon dioxide acidity. Now we are determining mineral acidity, and the indicator used is methyl orange. So you will be adding 2 to 3 drops of methyl orange indicator. The color should be orange. You have to titrate till you get yellow color. But we didn't get pink or orange, we directly got yellow, which means the minerals are absent. So mineral acidity is directly equal to 0 mg per liter. Therefore total acidity is the sum of carbon dioxide acidity and mineral acidity. But in this case we have only carbon dioxide acidity, but the minerals are absent. So you will be directly writing as 0, and you will be writing therefore total acidity is equal to carbon dioxide acidity is equal to dash mg per liter. So we will take another trial where mineral acidity is present. So let us measure another sample which has minerals. So we will be taking 50 ml of the sample in a conical flask. The same procedure is going to be repeated, where we are using the indicators phenolphthalein indicator, methyl orange indicator. Again the titrant is going to be sodium hydroxide of 0.02 normality, which is going to be filled in the burette. So we have taken another sample which has mineral acidity. So 50 ml is placed. So the first part, we are going to find out total acidity of this sample 2, where we are going to add phenolphthalein indicator. So 50 ml sample, phenolphthalein indicator, colorless, titrate till you get pink color. The end point is colorless to pink for carbon dioxide acidity. So initial burette reading you'll be noting down. So colorless to pink. Is it clear? So the sample has turned to pink. The end point is colorless to pink. You will note down the final burette reading. Therefore volume of titrant added is V2. Okay. mg per liter. Therefore carbon dioxide acidity is equal to V2 into 1000 divided by volume of sample taken. You get your carbon dioxide acidity in mg per liter. So second part, you have to determine mineral acidity. You are going to measure 50 ml of the sample. So 50 ml of the sample is going to be measured. It is going to be placed in a clean conical flask. So for mineral acidity, you need to use methyl orange indicator. You are going to add 2 to 3 drops of methyl orange indicator. You either get pink or orange. So in the last trial, we got directly yellow, which means minerals were absent. But in this sample, minerals are present. So we got pink color. We either get pink or orange. Titrate it against sodium hydroxide of 0.02 normality till we get yellow color. So end point for mineral acidity is pink or orange to yellow. Pink or orange to yellow. So can you all see the sample has turned to yellow. So you note down the initial burette reading, the final burette reading, then you calculate mineral acidity is equal to volume of titrant used into 1000 divided by volume of sample gives you dash mg per liter of mineral acidity. Therefore total acidity is the sum of mineral acidity plus carbon dioxide acidity. You're going to write the total acidity is equal to dash mg per liter, and you're going to compare with the standards. Maximal permissible limit for total acidity is 50 mg per liter, and you're going to conclude whether the sample is fit for domestic purpose or not. Thank you.